show you our final project for ECE 2001. This is our receiving circuit right here, and that is our transmitting circuit right here. We'll give like a breakdown of the components in here, and then in the receiving circuit, and then we'll show you a quick demo. So this is our transmitting circuit. Right here we have our ground. This is our positive supply from the 9-volt battery. And those come in over here. They're not in right now, but they go into these, they go into the power rails right there. So we have two inputs. We have the microphone right here, and we have the phone signal right here. So for the microphone to power it, we have 4.5 volts, and that's because we divided the voltage with two resistors that are the same, and then we power with 4.5 volts. Then the signal from the microphone, we run through a 10 microfarad capacitor right here. That then goes through a 430 ohm resistor into the inverting input on the operational amplifier. And from our phone signal, from the positive here, we run it through two series 22 microfarad capacitors, which is just equivalent 11 microfarads. Then that goes through a 2 kiloohm resistor into the inverting input. And then we have a resistor here across the top that runs from the inverting input to the output of the op amp. And also the op amp gets powered with a positive 9-volt supply, and then the negative supply we just ground, and then we just ground the non-inverting input too, with the white and the yellow right here. So then we chose 10 kiloohms and 2 kiloohms here. That gives us about a 5 times gain from our phone signal. And we chose this resistor as like 430 ohms, so this gives us about a 20 times gain for the microphone, which is a lot more because the signal from the microphone was a lot less. Then the output of the op amp runs to a capacitor to filter out the DC portion of the signal and protect backflow, just like these capacitors are used for over here from these two signals, because we just really want the AC. Then we use a bias T to add a DC offset to our signal, so that our laser is always powered on and it just oscillates from a laser intensity. So right here we run through a 100 ohm resistor from 9 volts to a 2.2 millihenry inductor. That meets the capacitor from the output. And now we could take the laser here, but we put another 100 ohm resistor in series with the laser, which is this red alligator clip. That's where the laser attaches to on the positive terminal. So we limit the current through the laser just so we don't burn it out with this 100 ohm resistor. And that is basically the circuit. The DC offset adds 9 volts, and then the signal from the capacitor oscillates between 4 and like 600 millivolts on the 9 volts, kind of like this, and then that's what changes the laser's intensity, which sends the signal across the room to the solar panel, which is the receiving circuit, which we'll get to in a second.
Alright, so this is our receiving circuit. We have our 9-volt battery taped to the top, which gets connected to these strips down here at power and ground, and we receive the laser signal right here on our solar panel, which starts by going through these two capacitors, which are in parallel, to give us, they're both 1 microfarad, which gives us a equivalent of 2 microfarads. which then goes through a 100 ohm resistor, and that resistor goes into the minus terminal of our op amp, and that gets feeded back into the, so from the capacitors we go to our op amp, which has a 100 ohm on the negative input and a 10 kilo ohm resistor that goes into the back into the output, and that gives us about a 100 times gain. And on the positive input of the op amp, we have to make sure to put 4.5 volts for a DC offset, and we get that from using a voltage divider over here with 2.7 mega ohm resistors, and we get the 4.5 volts right here. And then that goes, the output of the op amp goes to the two 22 microfarad capacitors in parallel and series, which gives us an equivalent of 11 microfarads, which then just gets fed into our speaker right here.
So our circuit works pretty well. It's definitely not the greatest. You can hear the music like slightly, and you can kind of hear the microphone too, but it doesn't transmit that well, but it does transmit, so that's good. So yeah, we'll just give you a quick demo and that'll be that. So this is the signal from the phone, positive, negative into here. That's just the mic. This is the laser. As you can see, when you press the laser, it turns on right there. And that, can you hold that? And that red light right there is actually oscillating in intensity, and that's what carries the waveform to our receiver. And now the demo.
Is it connected?
So as you can see, you can clearly hear the music. Not clearly, but you can definitely hear something that's oscillating from there, which is just this song right here. And yeah, and then our mic kind of works too. Let me keep the laser on. Now you can kind of pick it up, but not that well. But it's definitely there. So that's our demo. So that is our final project. Jason, it's been fun. Yeah. And that's about it. I will see you guys in the next vlog, hopefully. See you later.